All right, here we go. The lowest scoring AP FRQ of all times had to do with errors and power. So let's take a look at it. Now, when you have one of these, you need to make sure that you can grab for any points that you can. The number 6 is always an investigative task, an out-of-the-box thinking problem. It will start with something that you know and you are familiar with, and by golly, you better get your points on that, because once you get to the out-of-box thinking, who knows? Okay. Typically, the amount of points students get on those range in the 1.5 points. I think the highest has ever been 2.25 for a national average, but this one, the average was like 0.67, 2/3 of a point was the national average for this problem out of 4 points. All right, so they give us this here, describing context, a type 2 error. So the type 2 error is that the average, so that's when this is the reality. Okay, so type 2 error, reality, HA, so the average is actually higher than 122, but we did not get a sample that allows us to think that, and we think that the average is still 122. They did not ask for a consequence of that. I could see that happening, but they did not ask for that. Now we start getting into some problems. Now, this is interesting. I actually had to do this problem multiple times because I first had done it with t-distributions because it is about means. But then I went and looked and I was like, oh my gosh, look, they gave us the population standard deviation. And if they give you the population standard deviation, we can use z-scores and we don't have to use the t-distributions. So that got me. I had to end up doing this problem twice because of that reason. So here we go. So the question says, if the mean is 122, okay, then for samples of size 100, so n is 100, then we would know, so see the sampling distribution, okay, see, look, here we go. So then that sampling distribution will have a standard deviation of 1.5 because 15 divided by the square root of 100. And I could take off this degrees of freedom right here because we're not going to be using t curves. So what values of x bar would represent evidence to reject the null? So if the null is true, then they say with an alpha of 0.05. So what does this blood pressure need to be in the top 5%? So I need to find the z-score there. So inverse norm of 0.95 is 1.64. And then I solve for x bar. And keeping in mind that it's not just the number 124.46. It's any x bar greater than or equal to. So any sample greater than or equal to that 124.46 would lead me to reject this mean of 122. All right, so that's the problem that you should have gotten minimum. That would have gotten you 1 point on this problem number 6. Okay, so now let's see what happens from there. So from here, then we say, now, look, the actual systolic blood pressure is 125. So I got to thinking to myself, okay, so I need to draw a picture. I'm a picture person. I got to see concretely what's happening. So this is, your HO, and this is where the data would be centered if HO is true, but it's not. Our samples are really centered here. Okay, and we know that according to our test, anything greater than 124.46 would lead us to reject the null hypothesis. Okay, so that's what the question says. Using the actual mean of 125 and your results from part B, so that's this 124.46, what's the probability the null hypothesis will be rejected? So essentially what this is saying is, what proportion of samples are here that would correctly lead you to reject a false null hypothesis and detect what would lead you to detect we have this effect happening or whatever's going on. So that's what we have. We need the 124 and above with a mean of 1.25, and there's the standard deviation. So that's a z-score of negative 1.36, and all of these samples up here would lead me to reject. So that's 64.1% chance. There's 64.1% of the samples that would lead me to reject the null hypothesis. And what statistical term is that? What proportion of sample, what's the probability that you would reject the null hypothesis? If it is false, detect that, that's power. So now, suppose that the size of the sample of employees to be selected is greater than 100. What would the probability of rejecting the null hypothesis, would this probability be greater than, less than, or equal to the probability you calculated in part C? So what would changing the sample size, making sample size go up be? So that's this right here. So increasing the sample size, and it says explain your reasoning. I actually would have missed partial credit on this. So increasing the sample size will make the power increase. So that's for one. And I actually drew a picture. This came from our notes when we discussed the things that change the size of power. When you're making those sample size bigger, that's reducing the variability and sucking in the data, okay, getting more close. So that's what I wrote here. So increasing the sample size would make the standard deviation decrease. That would make the samples less varied and more closely clustered around the mean, okay? So that's important. That was needed to say that. Therefore, more samples would lead us to reject HO, so the power would increase. I would not have gotten full credit for that, even though I have that now. But the picture and the reason is because they required in the explanation that it makes this number right here, this sample right here, that would lead you to reject the null hypothesis smaller than it previously was. So because this is smaller, then that's why that's bigger, I guess. I don't know. Okay. So I would have probably just gotten 3.5 points on that problem instead of the full 4 points, but hopefully you would have at least gotten more than, maybe you would have gotten more than that one, and hopefully at least more than the national average of 2/3. All right. So good luck to you on that, and I hope that you understood errors enough to do well on that problem.